Hi. So, I'm Jordan Fink. I've been in class with you guys for this whole term, and most of us have never seen each other. So it's really nice to have the opportunity. Now, I am getting over a cold, potentially COVID. So, forgive my voice, which is off, and I might be coughing a little bit. This is a topic that's really close to my heart, which is urban chestnut agroforestry. And because it's the work that I do and it's connected to that, it was really exciting to put it into the framework of nature-based solutions. And at the same time, I could talk about this for hours and hours. So for the purposes of this assignment, I'm going to be as brief as possible, touch the important notes, and if there are any additional questions or if you're interested in learning more, even getting involved in the project, we need some good scientists in the project, please feel free to reach out to me. And pardon me as I cough and drink water and stuff like that. All right, let's get started. This is all left over from my streaming. I do education and teach, and sometimes I use Twitch in order to do that. So this is the framework that I use for that. So I want to talk about chestnuts and my project, to plant 1 million chestnuts all over temperate ecosystems, especially urban and residential areas. So I think about ecosystem change in a response to problems in terms of nested panarchies, which is pretty common in our field, but something that isn't done that much in a lot of other worlds, and people aren't as familiar with the idea that there is a heterogeneity in time and space in complex systems. So these are some of the frameworks that I like to work with. Scale permanence was developed by a geologist in Australia in the 50s. And he put together this basic model where we describe the largest systems of climate, setting the tone of landscapes, shaping land, shaping water, shaping how roads are designed, shaping how we structure our legal decisions, structuring how vegetation, microclimate, buildings and infrastructure, and down to the very smallest, the soil. So my nonprofit's called Build Soil because if we have things in line, if we have good ecology in line, if we have good land use in line, we have good road design in line, soil production is the result. And so it's a good measure, a good rubric that energy is stored, that soil's improved, that plants can thrive, that water is improving, all those kinds of things. I think having an understanding of hierarchies in complex systems is really essential, right, for knowing where the leverage points are. Because a lot of these systems, when people are dealing with giant global problems like climate change, they just really don't have the ability to match that scale, right? The climate is global. And so I find a lot of people feel powerless, or they only imagine organizing on the level of the atmospheric system. But the truth is, individual action, when it adds up to larger action, has the capacity to both have a good entry for people as well as scale up. So I'm always seeking projects that do that kind of thing. And the nice thing about a lot of nature-based solutions is that they are human scale because we share life systems with other living things. We're at the same scale as them. So the context is, of course, global climate change, we all know. And these are old stats from the beginning of the year. But we see what it is. We are above 417 million. We've lost the Arctic ice. Temperatures keep going up. Losing ice, all that stuff. I was raised in the context of permaculture, which was an attempt to apply geology, geomorphology, and ecology to land design. And there's a really basic idea: care for the earth, care for people, redistribute those surpluses. And this really is a complex system, right? These three ethics. We start by improving the basis of living systems. We use that to take care of social structures, and we use those structures to give back to the earth. And we know the problem. Rapid increase in carbon dioxide. That does not match the regular cycles of the planetary system. And this has obviously been driven by the consumption of energy, which has largely been the release of stored fossil fuels. But I think it's interesting to think about what we actually do with that energy. Because one thing we do is we obviously have the waste products and they go into the atmosphere and that increases climate change. But another issue is that we are using the physical energy itself to manufacture chemistry, to run explosions, to till the planet. And that is a huge impact. So just roughly, if we look at the amount of energy already used since the Industrial Revolution, equivalent of 90 million atom bombs of like the early atom bombs. And the amount of crude oil that we use every day currently is around 8,500 atom bombs a day. That is an impact of the planet. And one of the things that it's doing is changing a lot of balances. And it's causing erosion and it's shifting amazing things, right? That's what flings us across the planet. It's what manufactures things. It's what allows us to have communication across internet wires. So the energy released so far from that crude oil is only 1/100th of the energy of the impact of the asteroid that kills the dinosaurs. So think of this as a massive slow motion explosion. And there's some parallels. So it really is not a surprise that our work on the planet has had a huge impact, right? So in our quest for feeding human bodies, we need carbohydrates. And we get our staple foods primarily in this society, this civilization, through grain agriculture. And that impacts grasslands and grassland potential environments, which have the greatest potential for carbon sequestration and have just historically held an incredible biodiversity of life, supported some of the most fundamental parts of the atmosphere by holding on to massive amounts of carbon. We tear apart the surface of the temperate ecosystems around the planet every spring. And there's a huge plume of fossil carbon that comes out. And we know the impacts of this kind of stuff. Here's the Dust Bowl, the famous confluence of rapid tillage of grasslands and plains with a drought. And that confluence led to the atmospheric release of soil organic matter. And we have these records of what the Dust Bowl did. Massive declines in soil. And those soil losses have just increased over time. And this is happening still. So here's Phoenix, Arizona in 2015. That was the year that I had made a pledge for myself that when we started seeing Dust Bowl-like events again, it was time to devote to changing things again. So half the topsoil on the planet has been lost in the last 150 years. And that's not even counting all of the other erosion events before that. Soil degradation is a massive world problem, and it is driven by the human need for carbohydrates primarily, and we've used that to change landscapes. So we look at models of carbon, and there's this thing right here where it says that if you look at all the different pools, the soil pool is the second largest pool of carbon. And a lot of that is through plants pulling carbon, feeding it to microbes, and that getting embedded in a constant living process of soil exchange. So luckily, this is also a pretty fast process. And when the site conditions are right, they either annihilate soils or they can help with their rapid accumulation. We have that idea that soils are a slow process, and they are, but that tends to be more an issue of topsoil formation out of subsoil and subsoil formation out of parent material. That process is a complicated one. So we have topsoil, which has organic matter brought in by plants, and we have subsoil, which is just pulverized and transformed hard material. If you're a soil scientist, I'm being really basic on purpose. We know that successional systems over time build a complexity of fungi versus bacteria, and we know that the balance affects different kinds of ecosystems, primarily because fungi move ammonium and bacteria remove nitrates a little bit more. So this complex web, just to support a single vertebrate, massive amounts of soil. But we're losing it. So what happens when we lose this trophic pyramid? What happens when we lose the soil system to the vertebrates? This is the landscape that we've transformed to corn, right? These are the root systems. They had to fold them up for their display. We have We have bunch grasses here in the Pacific Northwest that live 500 years. These are old growth species sometimes. And that tillage, it just moves away the soil, down water, downstream, or blowing away. And you could say that one of the effects of agriculture, and this is I was trying to find a better chart than this, but one of the effects is that, so what this is showing is you have erosion rates on a log graph, and the area that is red describes agricultural impacts. And the cratons and soil mantled, those are normal lowland soils. Normal lowland soils do not erode, they accumulate. And when you start tilling soil, it starts acting like upland soils, not just uplands, alpine soils. Not good. We're changing the whole balance of erosion and deposition on the planet. So some numbers here. 1 part per million of CO2, this many gigatons of carbon. So soil needs to sequester 100 parts per million is about 367 gigatons of soil. If you spread this out to humanity, we would need to be producing about 108,000 pounds new soil organic matter per person in order to reverse climate change. That's not an easy task. It's not something that we're going to do probably in our lifetime, but it's nice to know where the best case scenario is so that we can aim towards it and we can sort of assess what percentage of that. And here we go. One study of pasture soils showed 38 tons per hectare. So Ratan Lal, the soil scientist, has put out some lowball estimates, and he's done that on purpose. And he's shown that somewhere between 66 and 90 gigatons is reasonable to say of how much carbon in the atmosphere is due to soil loss. So that's somewhere between 31% and 42% of the current problem is probably due to soil loss. This isn't talked about a lot in climate world, primarily I think because the climate models inherently don't like double accounting. And so land use has been only very cautiously brought into reports like the IPCC. It's not that it isn't a factor, it's that every year they're just adding a little bit more data from soil scientists. So without soil loss, potentially we would be at 376, 365, somewhere in there. Much more habitable planet. All right, so there's some variations of this, but it's obviously happening. And there's some work from people like Paul Redeman, who is, he's retired now, but he's a climate scientist who suggests, and this evidence keeps gaining ground, that the stable Holocene is likely due to the long history of anthropogenic burning, rice agriculture, and grain agriculture. That was just sort of keeping the planet out of its natural pattern towards moving into another ice age. And now we've gone and released huge amounts of old carbon into the atmosphere. But one of the things that he noticed is that there are these tiny little glaciation events, these mini ice ages, and almost every single one of them has happened after a plague. So his idea, which is being considered, it's one of the main hypotheses out there, is considered that with the loss of human agriculture, human land use, there was a rapid sequestration that caused ice age events. And of course, people eventually recover from plagues, which is great. But it does show that agriculture maintains a sort of kind of structure, and regrowing vegetation has the capacity to do this kind of work. So Lal estimates that just conservation agriculture could put enough carbon back into the atmosphere to offset 5 to 15% global fossil fuel emissions. And the Rodale Institute suggests that it could fully offset current emissions. So this is again, lowball estimates. Just a little bit of push, a little bit of good practices, and we are offsetting, some amount of our emissions. I would suggest that soil production can go a long way. We have a ton of topsoils. We could probably go a lot further. But here's a conservative estimate from people that are being cautious. So, I am not working directly with soil sequestration. At least not currently. I promote soil work. But I'm interested in how do we alleviate two things. The pressure of oh my God, the pressure of that we're putting on grasslands by demanding massive agriculture loads, right? The amount of soil loss, the amount of problems we're having in the Midwest, the use of fertilizers in order to keep soil productive, and the dead zones that come from 80% of the runoff of that, those fertilizer salts. So one of the alternatives is to think about how do we replace grain annual agriculture, at least in part, or give the option. So I'm interested in chestnuts because of a couple things. They are in the beech family, and that's interesting to think about the beech family of chestnuts, oak, beech, and the roles that they already play in temperate ecosystems and the amount of support that they give to temperate ecosystems. They've been part of the production of food in so many cultures. Italy, Corsica, Korea, China, Eastern US, other places, Middle East. And they're nutritious like a grain. They're actually not like a hazelnut. They're not as high in oil, so they're much more like a flour, and they can nutritionally replace it. They're easy to grow. So 2 chestnut trees can produce the amount of recommended grain nutrition for a person a year. When the trees mature, it produces that much carbon. Now, I'm not suggesting that we replace all of it with that, but the ability to regularly feed people from a perennial food crop. And these trees grow for 2,000 years sometimes. The oldest one that we have is between 2,000 and 4,000 years. They are capable of long-term growth and continually putting out food, while also making sure that people don't have to devote all their energy to constant retillage. This also means, though, that they can be a staple crop with room underneath. Other stuff can happen. Rather than cornfield, which, when I'm walking in my city, I can't imagine where we'd put corn, where we'd put wheat. The idea of local food for staple crops is pretty laughable, unless we devote some lands. But the idea that you can actually put chestnut trees and you can do other crops underneath, or cattle, or any of these things that have historically been done, or literally they can be street trees. And we love street trees, but most street trees are not multifunctional, right? They're just doing the job of being street trees. And people do fruit trees a lot. I love fruit trees, but I have to admit, there's a lot of messes that come from fruit trees, and they usually do not get cleaned up. And even an abandoned chestnut tree is usually cleaned up within a matter of minutes of the nuts falling, from squirrels, from people who have cultural traditions with chestnuts. So a case study example to inspire other fruit trees in other locations. So it's important that we understand that this is a solution for a time and a place, and that solution is the temperate ecosystems that tend to have acidic soils. So that's forested environments. That's the Pacific Northwest. It's the East Coast. It's not the deserts. Though deserts can be transformed over time, it's not a quick pathway. And chestnuts grow as far south as Georgia and the panhandle of Oklahoma, and can grow in Southern California, but as climate change happens, that band is going to get further and further north. There's other trees that can grow in other places. So it's important to directly feed people. And if we want people to be doing things like tree planting, developing food culture with that and dealing with food deserts at the same time allows us to solve multiple problems at once. And it's a perennial food. Oh, I already talked about that. So all over the world, chestnuts have been part of cooperatives, group action, collectives, festivals, feasts. They are a pretty powerful and cultural food. So let's talk ecosystem and ecohistory context. The last common ancestor of all modern chestnuts is somewhere around 20 million years ago, but 35 million years ago, all temperate ecosystems were in a band around the North Pole, in the Arctic. And those forests shared germplasm and had all of the genera that we think of as being in all of the northern temperate forests. And with the descent into ice ages, the trees made it south. Now, the trees that are in the beech family, which is beech is right over here. Oh, my writing went away. The small nut next to me is a beech. The one further is a chestnut, and the one on the bottom is an oak. And these are food crops, and they are the backbone of temperate ecosystems. And they're very closely related. And all of them provide food for all sorts of animals, from birds to deer and wildlife. And they provide incredible food for people as well. One main difference with chestnuts is that chestnuts are much larger They're much easier to process. They do not fill themselves with tannins the way that oaks do. And they do produce every year, while beech and oak are both trees that take time off because they are trying. It's interesting. They're trying to stop squirrels and nut thieves. If they grow too many, you get an explosion in population. If they wait a year, take time off, they keep the population low. Chestnuts just pile in the nuts and cover with spiky balls and compost and just try to outcompete the squirrels that way. And, this is the beech family. So we've got the carpus, we've got castanea is the chestnuts, and castanopsis is the some of the chinkapins. And I guess at the bottom is beech, and quercus is our friendly oak. This is where all the beech family trees ended up at the moment. This is where we have all of our beech family trees. And so this ends up being sort of an appropriate area for chestnuts, though the North American beech go a little further south, and the Southeast Asian beech family trees are a little too far south for chestnuts. And this is where the residual populations of chestnuts made it when they went south. So the American chestnut, which people really love to talk about, I don't work with as much because of its tragic history means that it is not a very good gene pool, which is why people can experiment on it right now without causing too many problems. And but it was generally one of the reasons why there's very low genetic diversity in the American chestnut is because it was an agricultural crop primarily. Probably came south during the ice ages into small refugia, and native people developed it as an agroforestry crop and spread it over a wide area. Now, in Europe, the European chestnut, which is very sweet, very good for flour, probably started around Anatolia, that area, and then was spread by people because it's such a useful tree in the Mediterranean. Again, it came from a couple different refuges post-Ice Age. And then we have the Chinese chestnut, which is tall and a good timber tree, but also a very edible chestnut. It has the highest genetic diversity of any of the chestnuts and probably reflects the genetic diversity of the original population in the Arctic. Talking with some paleobotanists, we were discussing this, and somebody said basically that the entire phenotype of the Chinese chestnut in China, which we don't have very many of them here, encompasses completely the phenotypes of the American chestnut, and they should not be considered a separate species. All of these can interbreed. The main difference with the American chestnut is as a tiny nut that's hard to get into. It probably co-evolved for a while with the passenger pigeons, which had a very nice relationship with it. And then in China and Korea, there's another chestnut, the Japanese Korean chestnut, which is, I would say it's not as flavorful, but it has incredible disease resistance. It is the most blight resistant of the trees. And at this point, it's being crossed into all of the other populations. So, human beings found these trees, spread them, and they started the chestnut civilizations. We know that in Anatolia, Catalhayuk, and some of those places were originally chestnut and nut foods before they got really into grain agriculture. Chestnuts have spread throughout Western Europe and was a big part of the Roman Empire. We know that France and Italy and Corsica are all centers of chestnut culture. And then in China, chestnuts are a regular part of diet. They were even bigger. We know that the Yellow River Basin was primarily a chestnut agroforestry system until rice agriculture got so intense and started spreading. And then Japan and China also have great cultures of chestnuts. So here's some European chestnut facts or some information. Up at the upper corner here is Italian partisans fighting fascists. And when I've been working on my project, I keep having children of Italian families come to me and say, my grandparents have said that I must always plant chestnuts. And I'm like, oh, food? And they say, no. My grandparents were partisans, and we survived difficult times by living on the chestnuts. And then far is the Corsican pigs. And Corsican pigs are raised primarily on chestnuts, which makes them very delicious. Corsica has a cultural policy of planting many trees per household, and they're probably the most like committed to chestnuts of any European societies at this point. Here on the bottom is a famous chestnut tree known as the 100-horse chestnut. Now that's because horses can go around it, 100 horses. It's not a horse chestnut. It's not related to those. But this tree has been rated at between 2,000 and 4,000 years old. These are long trees that keep producing. It's at the base of Mount Etna in Sicily, or near Sicily. And there's like woodcuts. This tree's been around forever. So the challenges. So we do know about the chestnut blight. Now the blight hit in 1915 in New England, and it probably came from China. But the chestnut blight infects trees all over the world other than the Japanese chestnut. It's not that big of a deal for the Chinese chestnut, and it is a mixed bag for European chestnuts. It's a bad disease, but it's not a killer on the same level. American chestnut was hit pretty hard. We also know that at the time of the blight, there was an active cutting of American chestnut trees, so the people annihilated the trees at the same time. And the deal with that is that there's not very many left. Their diversity is pretty low. There's an effort right now to inject genetic engineered trees into the population of American chestnuts, which I personally don't like for many reasons, including that it creates a even more bottlenecked parentage of the surviving trees. We need to be producing as much diversity in populations, because blight is not the only disease. There's root rots, and there's scalds, and there's nut rots, and over here in the corner, there is the chestnut weevil. We are very lucky in the Pacific Northwest. We don't have most of these diseases. So there's a heavy quarantine against new trees being brought in without rigorous care. Yeah, they have weevils on the East Coast, and you can handle it just by making sure that you put your chestnuts in the oven at low heat when you do your harvest. So it's a pain in the ass, right? But it's not a death knell for the tree. Most trees are pretty resistant, and the ability of people in order to create these things. So I'm going to shift to this pretty quick. I'm taking a lot longer. Like I said, I can talk about this. We know that there's been a general European abandonment of chestnuts. They are not in vogue. Landscapes are getting abandoned in the Mediterranean. But there's a modern agroforestry movement. And in Corsica, man, they're just like fighting hard and recommitted to the chestnuts all the time. Stakeholders in our project include, we work with the USDA a little bit. Well, we work with a retired USDA professor who's trying to like track old historic chestnut introductions. The project directly, though, is working with, this got doubled. I didn't mean to double it. Working with neighbors, working with farmers, working with churches and schools. We've been handing out chestnuts, and not on this list, because I doubled rather than wrote the thing I meant to write. We work really closely with governments, because not everybody in every government is thrilled about giant chestnut trees being part of the street tree. Here in Portland, they were legalized for a lot of arguments that have to do with that they're incredible trees, and that they feed people, and that they only make temporary messes that are pretty easy to clean up. Not every city has approved these trees. On the East Coast, they tend to only want to go for the American chestnut, which isn't a very healthy option for success. And then on the West Coast, they're just unfamiliar with the trees. We also work with parks and planting these trees as part of the pastoral landscapes. They basically can go anywhere that you could plant oaks and be part of that ecosystem pretty healthy. So I have a nonprofit, and we've been working on these kinds of projects. And we're trying to inspire 1 million edible chestnuts for community building, food resilience, and changing agricultural impacts on the climate. The main strategy is community organizing. We need people who feel like they can do something about climate change. And so I work with people. I work with citizen groups, work online. I have a Twitter account that is pretty popular. And we get people to come together, plant a few nuts. You can actually plant 25, 30 nuts in a 4x4 square, and then distribute them to your community. So we get people to do that, and they do this very simple project, and they find other friends and other neighbors, and they start talking to their city about, well, where can we put these? Do you want these in your school? Do you want these in your backyard? And we build community cohesion that way. And then our monitoring and expansion is pretty simple. I'm working with GIS tools in order to do citizen science. have people mark where they have their trees and do observation. I'm very inspired by the work that the Chicago Field Museum is doing with their butterfly hub, where they instruct people on how to plant butterfly gardens and then do monitoring and report back. So our process, I already bought and collected 12,000 chestnuts and we distributed them. I planted them in my backyard. You store them in buckets. You store them in your refrigerator. And then in the spring you plant them in little nurseries. Or you take trees from people who have done that and you plant them in a final location. They need to be about 25 to 60 feet apart from each other. And sometimes I recommend people doing a 5-foot planting instead, with the understanding that they're going to cull them after a few years. So we have to find places for them, and that is one of the big processes. And it gets people out there talking and interacting with each other. We've been working with land trusts, we've been working with religious sites and communities of faith. And I have seen people in all sorts of cities all over the world start to have conversations with their local governments about, well, we have a group of citizens, we'd like to do this thing. How do we get involved? Oh, it's not approved yet? Here's how we strategize. So, just so you know, here's the difference. The one right here is a horse chestnut. It is poisonous. Do not eat it. And the farther one, that's the edible chestnut. And there's some mnemonics you can use. The bad poisonous chestnut, it looks like the Koopas from Super Mario Brothers. But the good chestnut looks more like a koosh ball. And here's a good chestnut. And then the one closer to me, that's edible. And the one further, that's poisonous. So we have some good examples of people doing really interesting projects. Mark Shepard here in Wisconsin, doing massive genetic diversity plantings and planting them together, allowing them to breed over and over again. It's so far north, it's a little cold for them. They get some die-offs during Arctic vortexes. And then here's a Kiva Silver who really, he's the one I learned the hyper dense planting from, where we plant them only 2 to 4 inches apart from each other. And it works great. I've had huge successes. So you harvest chestnuts, you put them in buckets, you bury them underground so that they don't freeze, or you keep them in bags in your fridge. And we were really inspired by, I'm really inspired by the work of desert harvesters who do something very similar but with mesquite. And they have got people to build water catchment in the sides of the streets, plant mesquite, and then they have community milling and food production. They have a pancake breakfast. Everybody comes together on their community mill and eats mesquite, traditional foods, native foods. And they've done a good job of promoting all sorts of Sonoran desert foods. And they've got this pancake breakfast fiesta stuff that they do. So here's a chestnut tree by my house, and they're just incredible trees. And here is a chestnut tree by my house where I just went out for an hour and just quickly went and harvested. And here's chestnuts that can be put in, I steam them, I tend to cut them and then put them in my pressure cooker. And they're like potatoes, or maybe a little sweeter. They're very good. And then I dry some, and we mill them and make them into flour. I just had chestnut pancakes this morning. This is our first run where we were actually growing them in buckets because I hadn't worked out my perfect system yet, and I wasn't sure how long I was going to be here. But here they are, planted inches apart from each other, and then they were transplanted. Took a backyard, just a tiny little normal backyard, covered it in a layer of soil, planted chestnuts, and then we had trees. Oh, let's see if I can get this to work. Just so you can see what it was like that first year. Now I have a system that's way more organized. But you can grow a ton of trees in a small space. This is meant to demonstrate to people that they can just do a small version of this. So, and then this is, that's, I believe, 30 trees. No, yeah, that's a 4 by 4 foot area. So this could be done in anybody's little backyard. And then, since this, I learned tying ribbon around it so I can see the trees in the winter. and we harvested them while they were still bare root. There's 100 trees in my hand right there. No, sorry, 50 trees in my hand. And our first year, we harvested them and handed them out to lots of people. I gave them a lot to churches. And about 4,000 of them we sent to Native communities in Western Washington who distributed them and planted them for food resilience. And so the goal is, here we are. We can have food, we can have culture, and we can be making better environmental decisions. We can be sequestering carbon. We can be getting our food high over our heads from the built environment, within the cities. And it's pretty incredible, this idea of a food culture. And every time I bring people together to help in the backyard nursery or to work harvesting trees or to go visit trees, we're doing a lot of ground truthing, confirming that the maps are accurate. And hopefully we'll get a little bit more interested in varieties and all that kind of stuff. But this idea of like urban production, urban food production has always been a little bit of a pipe dream, it seems like. And now it feels like we actually have a food that we could do, that we could grow here. There's lots of details, lots of other stuff. I'm happy to talk about it. I took a long time in this talk, so my apologies for the time. But it's such a rich topic, and I'm just really excited about it. Okay, well, thank you very much for your time. Happy to answer any questions, and hope everybody has a good rest of their day.